Picture this. You've set up an ESP32-based smart irrigation system that works perfectly in your lab. But once deployed on a farm, the Wi-Fi router reboots, or the signal weakens, and suddenly your device stops reporting. That's when you realize connecting once isn't the challenge. The real challenge is staying connected without human intervention. In this lesson, we'll focus on exactly that. You'll learn how to connect your ESP32 to a Wi-Fi network, monitor connection status, and recover from disconnects gracefully. By the end, you'll know how to make your device resilient, so it can survive in the messy, unreliable conditions of real-world networks. Let's ground ourselves in the fundamentals. In most IoT deployments, the ESP32 operates in station mode, which is like your phone joining a Wi-Fi router. To establish a connection, the device needs the SSID, password, and Wi-Fi mode. But here's the nuance. A single connection attempt is never enough. Routers can change channels, signals fluctuate, and power interruptions happen. If you don't manage disconnects, your device quickly becomes useless on the network. Think of it like driving. You don't just start the engine, you also monitor fuel, speed, and warning lights continuously. Similarly, Wi-Fi connectivity requires continuous monitoring and smart recovery strategies. That's why professionals never rely on blocking loops for Wi-Fi, but instead adopt event-driven handling. It's what transforms fragile demos into reliable systems capable of running unattended for months. The ESP32 provides a powerful mechanism for handling Wi-Fi issues, system events. These are notifications triggered whenever the Wi-Fi state changes. For example, when your ESP32 connects to an access point, it fires system_event_st_connected. When it gets an IP address, you'll see system_event_st_got_IP. And when it drops from Wi-Fi, you get system_event_st_disconnected. By writing an event handler, you can decide how to respond dynamically. Maybe print the new IP, attempt a reconnection, or enter a fallback mode. This is like having a copilot giving constant updates about altitude, speed, and turbulence. You don't fly blind, you adjust as needed. Importantly, using event-driven handling keeps your main loop clean and non-blocking, which means your sensors, actuators, and timers continue to function normally even while network recovery is happening in the background. Here's a quick reference map of the most important events in station mode. When your ESP32's Wi-Fi state changes, one of these events fires. If you handle them properly, your device becomes self-healing. For instance, system_event_st_connected confirms you've joined the access point. Usually you just log this. System_event_st_got_IP is when the router assigns an address. This is the moment to start network services, like MQTT clients. And system_event_st_disconnected signals a lost connection. This is where you retry after a short delay or enter a recovery routine. Treat this table as your cockpit dashboard. Ignoring these events is like ignoring a warning light in your car. It may run for a while, but you'll eventually face a breakdown. With events, you can debug intelligently and recover without freezing the rest of your application. When Wi-Fi drops, how you handle reconnection determines system reliability. Beginners often use while Wi-Fi.status is equal to WL_connected loops, but these block everything. Your sensors, actuators, or timers freeze until reconnection happens. A better approach is event-driven retries with delays. For instance, retrying every 5 to 10 seconds prevents router overload and reduces power drain. On battery-powered systems, use exponential backoff, meaning each failed attempt waits longer than the last. This saves energy and avoids network spam. And don't overlook logging. Simply printing the reassigned IP has solved real factory issues where DHCP was to blame, not Wi-Fi. Always test reconnection under stress. Router reboots, signal drops, and wrong passwords. If your ESP32 passes those scenarios, you can confidently deploy it in the field. In this lesson, you learned how to connect the ESP32 to Wi-Fi in station mode, and more importantly, how to keep it connected reliably. We explored techniques for monitoring connection status, detecting and handling disconnects in real time, and implementing automatic reconnection strategies. You also saw how to use logging to track issues for debugging in the field. Together, these practices help you move from lab experiments to building robust, field-ready IoT systems that stay online without manual intervention.